everybody, I am Nifreke Owa. In our previous tutorial, we discussed about the rewinding of an alternator, single-phase alternator. We ought to have continued in the rewinding of three-phase alternator and other electrical machines. But because of appeal from my audience to carry out a tutorial on installation of solar panel and solar system entirely based on my experience in the line, I choose to pause a while and bring up this tutorial. The diagram shown is the diagram of solar panel from the panel down to your load. Perhaps your load may be your building, your house, maybe your fan, maybe whatever load you have, AC load you have. So on the board here is the solar panel. We are using block diagram to explain these circuits and connection, because I believe block diagram is easy to follow. Whoever wants to carry out the installation himself, block diagram is easy to follow than the symbolic diagram. That is why we choose to represent everything here in block diagram. We have from top here the solar panel. We have panel A and panel B. This panel is connected in series. It could be connected in series and in parallel, just like your battery. When it is connected in series, you want to add up the voltage. The voltage is additive. If you could recall, voltage is additive in series connection. If you are connecting the panel in parallel, you are adding up the current. The voltage will still be the same in parallel. So, but here you can see we have panel A has 6 volts, panel B has 6 volts. If you connect them in series, that is linking the negative to the positive, the negative of panel A to the positive of panel B, and bringing out the negative terminal and the positive terminal, you have them now connected in series. What you have at this point is 12 volts. Okay, so we have 12 volts from the panel up to this point. What we do practically is we have interest in protecting our components, mostly this electronics component like the charge controller. That is why we use, in between the panel and the charge controller, we introduce a DC circuit breaker, single pole, that is positive and negative single pole, so that the DC breaker, in case there is spike in voltage, perhaps there is thunder strike or there is sudden spike in voltage from the panel, instead of the spike to come directly to the charge controller that can damage the electronics component, the breaker will trip and save their charge controller. Charge controller is somehow expensive depending on the capacity of their solar system. Okay, so we have here a block of DC circuit breaker. The connection is just as it is. The positive just go, the negative come, and your outlet terminal, you take it out from your outlet terminal down to your charge controller. And now we have the charge controller. Normally the charge controller, depending on the type, it has, since it is a DC component, you will see indication of positive and negative, positive and negative, positive and negative. Some charge controller has battery, sign of battery written. That is where I use B for battery. And the other one you see load. Some charge controller will show you a bulb symbol telling you it is load. You have to connect from here. And here this SP means solar panel. So your two terminal, your two 12 volt terminal will come to the positives and the negative of your charge controller, and positive and negative from the battery. You take off positive and negative from the charge controller to your battery. Okay, you also go to the load, you will see positive and negative. The difference between here is the charge controller will charge your battery at the same time delivering the voltage to your inverter. That is in the daytime where you have sunshine, okay, enough, so it will deliver your 12 volt to the inverter. Okay, and this is your battery. I just choose to connect them. You see now they are in parallel, the same voltage, because it is 12 volt in parallel. It is not additive, it is the same voltage. so they will come. What happened at this point is, if in the daytime suddenly the sunshine go down, okay, your battery will deliver immediately to your inverter. Okay, when the sun come back again, your battery will still be charged and your load will still be delivered. Your load terminal will still deliver the 12 volt to the inverter. Okay, this is the block diagram of the inverter. The inverter has also positive and negative terminal at the inlet, because at the inlet it is DC. Okay, remember, DC must always go with positive and negative charge, positive and negative sign. Okay, so now this is the inverter. Remember, your inverter converts your DC volt to AC volt. Your inverter will convert the voltage, it is a circuit to convert the voltage and send it to the load. But what we like to do is we like to make sure our system is protected. That is why in between the inverter and your load we have AC circuit breaker, so that if there's at any time you have short, maybe your load is short circuited, or you have any issue or thunder strike, your load need to be disconnected, the breaker will trip instead of coming back to affect your inverter. That is why we have AC circuit breaker. And remember, the AC circuit breaker has to be calculated based on your load, so that it will not be oversized. If it is oversized, it will not protect your system. Okay, that is where we have up to the point of your load. Remember what I told you, this your load connected, it is AC, so you don't see the polarity. It's where you have the polarities here are in DC supplies. You have polarity, positive and negative. If you follow it the way it is, definitely your inverter system will work effectively. Okay, up to the point of your load. I represent this load in the block diagram. It could be your AC, it could be your lamps in the house, it could be your television, it could be your fan, it could be whatever load you have AC. Okay, it is connected from the outlet of the circuit breaker. Okay, from the circuit shown, the circuit indicates it is only one battery that is connected. Okay, in other cases, this battery is rated in ampere hour. In other cases, there may be need for 2, 3, 4, 5 batteries connected either in series or in parallel. Okay, so we will also explain to you how to connect this battery here in parallel and also in series in case it is 2 and above. When it is more than 1, it is connected the same way the solar panel is connected, just as it is shown in the next diagram. Okay, so note the difference between this block diagram and the one just explained. In this one, we want to add another battery to the system to make it 2 or 3 batteries, okay, connected in parallel. Why we want to connect the battery in parallel is to give you more ampere hour. Okay, in parallel connection, as I have explained before, the voltage is the same, current is additive in parallel, but in series, voltage is additive, current is the same. Okay, these three, we have battery 1, battery 2, and B3, battery 3. Okay, it has the terminal positive, negative, positive, negative, positive, negative. As I have told you, the 3 battery will be connected in parallel for us to have an increase in the ampere hour. Okay, to connect this battery in parallel, all the positive will be connected together and all the negative will also be connected together. Okay, so by so doing, outlets from the positive and the outlet from the negative will all go to the inverter. Okay, remember the inverter has positive and a negative terminal. Okay, so just note the way the batteries are connected. So just note the way the batteries are connected in parallel. Okay, this point I'm going to explain now is very, very important. In some cases, what we do practically in the field is, since this charge controller is an electronics component, if you connect the load terminal of the charge controller to the inverter and at the same time connect the battery terminal of your charge controller to your batteries, there's tendency the charge controller will spoil very soon. Within a short period of time, you may notice that its efficiency has dropped. So what we do most times is we don't connect the load terminal to the inverter at the same time while the battery is charging. So we connect the battery directly to the inverter, and we allow the load terminal floating as it is. So by so doing, the charge controller seems to work effectively, because the two sources are not supplying to the load simultaneously. So that is what we do practically, so it works that way more efficiently. Okay, let me come back to the battery parallel connection. In battery rating, it is rated in ampere hour. Some battery, you will see battery 200 amps hour, some will be 250 ampere hour. So this means that within your battery, any battery that is rated 200 ampere hour, within an hour it can effectively give out 200 amps. Okay, so if you want to supply your load for 2 hours, then you reduce your load to 100 amps load. By so doing, your battery will stand 100 amp load for 2 hours, and so on and so forth. So now, if this our battery each is rated 200 amps hour, battery B 200 amps hour, battery C 200 amps hour, by connecting them in parallel, you've succeeded having 600 ampere hour battery. Okay, so when they are fully charged, you are sure that you can supply a load of 600 amps, okay, for 3 hours. You can supply a load of 600 amps for 3 hours. If the lower your load, the longer the time your battery can supply your load. So this point is very, very critical for you to note. Anytime you want to increase your current, connect your battery or your solar panel in parallel connection. The more they are, the more your current you have. If you need voltage, connect them in series connection. Your voltage will increase the more your battery or your solar panels are. So at this point, I believe it is very, very explanatory to connect your solar panel from the solar down to your load. I can easily run through it again. Remember, the panel is there are 2 panels, 6 volt connected in series, and that is why you have 12 volt DC coming to your DC circuit breaker. The essence of the DC circuit breaker, it is not compulsory, but it is necessary, is that it saves your charge controller in case there is spike in voltage, perhaps due to thunder strike or whatever might have happened. That is why we have that DC circuit breaker. It has to be sized according to your component. It shouldn't, if the current you have here is not something more than 20 amps, you can't bring a circuit breaker of 100 amps. It is a wrong design. Your system will not be effectively protected. So from your DC circuit breaker, you have your charge controller. You know, the charge controller have 3 terminals with positive and negative polarities. The first one from your solar panel, that is why you have SP solar panel. Okay, the positive and the negative of your solar panel will come to this point. The battery, that is why you have B, will be connected to this point, usually in the middle. Okay, the third one is the load, will be connected down to the inverter. Remember what I've just explained. At times it is very advisable that you don't connect the load terminal to the inverter and at the same time charge your battery. We prefer practically to connect your inverter via the battery while the battery is charging, okay, in order to save the life of your charge controller. Because if you are connecting the load down to the inverter and the battery terminal down to the battery at the same time they are working, the charge controller may be overworked and it will reduce its efficiency. That is from the practical point of view we have noticed. Okay, I've just explained that the batteries here are connected in parallel in order to have additive current. Okay, all of them are 12 volt battery. Because they are connected in parallel, they are giving you 12 volt direct to your inverter, while your current capacity is being increased. Each of the battery is rated as 200 amps hour, that is ampere hour, and 3 of them will give you 600 ampere hour. So you are sure of 600 amps for 1 hour or 100 amps for 6 hours, depending on what your load is. So from your inverter will invert the DC to AC and send it to your load. We have carefully, designed the system with the aim of protecting your system as well. That is why we have the AC circuit breaker connected in between your inverter with your load, between your inverter and your load. The AC circuit breaker is very important, so that wherever you have short circuit within your load. This load may be your house, it may be your fan, it may be your lamps, it may be your AC, it may be whatsoever load that is consuming power. That is why we have it. So the AC circuit breaker will protect your devices, your inverter, from your load in case there's any short circuit within your load. The high voltage shouldn't strike down your inverter. So that is where we have up to the point of load. I believe this is very explanatory to you. We are representing everything using block diagram. We have chosen not to use symbolic diagram in order to make it confusing. So I believe with this you can easily follow the diagram and have the solar panel well installed and functioning. Thank you for listening to us. Like the video and follow up our subsequent video. This is Easy Grab. Thank you.